Hey guys, Sam here from Qt Lab, and I have a question for you. Is there anything in the world more fun than making music? That's right, there's only one thing, testing, and one other thing, calibrating your Eurorack gear. So in this video, I'm going to cover testing and calibrating mom jeans. This video is primarily for people who bought the mom jeans DIY kit, but you can also use it to calibrate your mom jeans, recalibrate it if for some reason you want to do that. You will need a voltage source, a known voltage source. I've got here my Expert Sleeper's disting, which in the precision adder mode can very easily give me, say, 0 volts, 5 volts, minus 5 volts. You'll need a source, a stable source of 5 volts and minus 5 volts, and this Expert Sleeper's disting can also just do, 1 volt, 2 volt, 3 volt, minus 1, minus 2, minus 3, which is also useful for the more precise mom jeans calibration. We'll get to all that in a second. Point is, if you have a known calibration, or you must have a known calibration source, a source of some stable, precise voltage to do the calibration. For testing, it's also very helpful to have an LFO. It's got a square wave LFO here, really, really helpful. And this module just puts out a constant CV voltage, and I can configure that voltage by turning this pot. Anything here will do, an LFO, just something that puts out some CV. We'll use this later to test that all these jacks actually do something. So we're going to calibrate and test. Testing, of course, is just about making sure that, all the inputs do something, all the knobs do something, the toggles do something, the inputs are reading and the outputs are, putting out some audio. We'll talk about how to do that last. First, we'll talk about how to calibrate mom jeans and what calibration means for the module. But even before that, the very first thing that will happen after you build mom jeans, you'll plug it in and you want to do the very, very basic testing just to say, is it even on? Is it working at all? When you plug mom jeans in the first time, you should see something like this. Cadence LED illuminated, and this button here, when you press it, it should toggle between that illuminated and not illuminated state. That means the firmware is running, the module's on, it's more or less working in the most basic sense. If that's good to go, you can move on to calibration. So in calibration, we're trying to do 3 things. Number 1, all the knobs and the toggles, we want to give those a minimum and maximum voltage, turn them to their most extreme values, so those can record those values and normalize themselves internally. Number 2, all the jacks should get a 0 voltage, or they should take a reading when there's nothing connected so they know what 0 volts looks like. Finally, these 3 inputs, the volt per octave input, the linear FM input, and the FM index input, should all get a known voltage, 5 volts and minus 5 volts, or if you're using the more precise calibration mode, every voltage from 0 to 8 and 0 to minus 8, those discrete voltages. To enter calibration mode, what you do is press and hold the calibration button here. This calibration button, when you press and hold it, you'll see these 2 LEDs start to blink like this. That means the module is in calibration mode. There are 3 calibration modes, and you can cycle between them by pressing the calibrate button. Now I'm in calibration mode 2. You can see that because the LEDs are blinking twice and then turning off. And in calibration mode 3, they'll blink 3 times and then turn off. Once you go from calibration mode 3, you push the button 1 more time, and this takes you back into normal module operation. When you do that, the module saves whatever values it received during calibration. So that's also how you write calibration. When you're in calibration mode, I'll go back by pressing and holding. When you're in calibration mode, you can press and hold calibrate to erase calibration. That flashing pattern means that the calibration data on the module has been erased. It doesn't, when you enter calibration mode, it doesn't automatically erase calibration. Rather, any new values that you send to mom jeans, it will just add that calibration data on top of what's already there. So you press and hold calibrate when you're in calibration mode to erase calibration data. Okay, let's actually do the calibration. So to do that, I'm going to press and hold calibrate, enter calibration mode. Right now we're in calibration mode 1. In calibration mode 1, all of the audio inputs are just expecting a 0. So they're all taking a reading right now and recording that as the 0 value. And that's useful later for when they get voltages that are big or readings that are bigger than that. They'll know it's positive voltages. Smaller than that, they'll know those are negative voltages. In any calibration mode, we can calibrate the knobs and the toggles. You do that just by turning the knobs to their lowest value and highest value. And this just makes sure all those, all the pots are calibrated or normalized to the minimum and maximum values that they can read. I'll do the same with the toggles. Now I want to calibrate to a precise voltage, the volt per octave, linear FM, and FM index inputs. So to do that, I'm going to go to calibration mode 2 by pressing calibrate one more time. Now those three inputs are expecting a 5 volt and a minus 5 volt source. So I'm going to take the disting here and grab a 5 volt source and just connect that, make sure the connection's good, and then connect to volt per octave, linear FM, and FM index. Okay, then I'm going to grab minus 5 volts and just connect that to volt per octave, linear FM, finally FM index inputs. And that should be the module calibrated. That's all you need to do. If when you test, you find that the volt per octave, for example, that input is not as precise as you want, you can use this calibration mode 3, the most precise calibration mode that actually will account for any nonlinearities or something going on with a particular input. And to calibrate in this mode, you actually plug in a 0 volt input and then step up discretely, so in steps, to 8 volts, and then plug in a 0 voltage and step down discretely or in steps to minus 8 volts. So I've got 0 volts here. I'm just going to connect this to the volt per octave input and then step up 1, 2, 3, 4, 5, 6, 7, 8. Unplug that, go to 0, and now step down minus 1, minus 2, minus 3, minus 4, minus 4, minus 5, minus 6, minus 7, minus 8. And that should give that a very precise input. So it's got a reading now for each known voltage. And if I push calibration one more time, that's written calibration. And now the module should be calibrated, and we can move on to testing. So in testing, we're doing, well, we want to make sure all the inputs actually do something, and we want to make sure that the outputs are working, the audio outputs are working, and then we'll make sure that those calibrated inputs are actually tuned correctly. So first, let's make sure that it's working at all. So pitch should change pitch. Density should change density, sounds about right. Cadence should change the rate at which that LED flashes. And with torque up, torque should control the depth of that modulation, and it does. And this shape knob should take us between different waveforms, and it does. The toggles should change how how the rate of calibration, how turning the two toggles should change the rate of calibration, how exactly that is a function of what position the pot is at. They both seem to be working. Now we can actually just check the audio inputs. So let's check that density is working. Let's check that cadence is working. So I'm looking at the LED here. Seems to be working. Did I turn the right knob for density? I don't remember. I think I turned the wrong knob. Anyway, that seems to be working. Let's try torque. Seems to be working. Let's try shape. Seems to be working. Now we can check these calibrated inputs. So I'm going to set my expert sleepers to 0. plug this into volt per octave. I should expect to step up and down in octaves. Sounds good to me. Let's try linear FM. Here I should be because the FM is linear, we should step down an octave and then to 0, but we should be stepping up in fifths, a fifth at first, and then up to an octave, and then I'm not sure exactly, but you'll hear what that sounds like. That looks good to me. Now let's, to test the FM index. FM index controls how big an effect the linear FM has. So a nice way to test this is just to plug some kind of LFO. Let's try an LFO into linear FM. And then FM index here should control how big that excursion is. Sounds right to me. And lastly, we can test, I think I forgot to test yep, okay, just making sure that works. Lastly, we can test sync. I guess we should check the square output too. Yep, that's good. Lastly, we can check sync. So sync resets the phase of the internal pulse train. So when sync gets a square wave input on a rising edge, you should hear a click. And then at fast rates, we should hear a timbral change, and that's just what we hear. So unless I'm missing something, that should be the whole module tested. Common things, if you don't like the tuning, if the tuning for volt per octave and linear FM doesn't sound right, just go back into calibration mode, run that calibration again, and then everything should work the way you expect. So there you go. That's Mom Jeans tested and calibrated. Please don't hesitate to get in touch if you have any questions. We're more than happy to help. Thanks for supporting us here at Qt Lab. Enjoy the module and take care.